Hello everyone, for this tutorial video, I'd like to explain how to take higher order derivatives, which are derivatives that are repeated more than one time. For example, if we are given this function, we should be well versed with the basic differentiation formulas in order to take the derivative of this. If we take the derivative of this again, we would write this as function double prime of x, and we would call it the second order derivative, or second derivative for short. So the original derivative would be called the first order derivative or first derivative. Similarly, if we take the derivative of this, we get the third derivative, which we can symbolize with 3 primes. Another convention you will see for higher order derivatives, because of the fact writing many primes in a row would get tedious after a while, is to symbolize in parentheses the number of primes you wish, which should not be confused with function raised to the power of something. So the parentheses make it clear that we are asking for a higher order derivative. We can see, provided that our function has specifically a power of a positive integer, so no fractions and no negative numbers. If we take the derivative of the function enough times, it will always eventually reach 0. Similarly, if we take the derivative of cosine or sine enough times, it will eventually repeat right back to cosine or sine. And if we take the derivative of e to the power of x, it will always stay e to the power of x no matter how many times we take the derivative. However, almost all functions, besides these 3 types, will not give you neat patterns, but rather will get more messier to predict the more derivatives you take. We can see a second derivative with reference to implicit differentiation is, we find the second derivative of y and x squared plus y to the 4th power equals 10. We take the first derivative like we did in the implicit differentiation example, and we see the second derivative must be the derivative of this answer. So since we are differentiating with respect to y, we treat x as a constant and use the quotient rule. After some algebra to simplify the problem, we get our final answer for the second derivative of y. One last thing to note is that just like there is an alternative notation for the original derivative, there is an alternative notation for higher order derivatives, where the second order derivative can be rewritten as d squared of y over dx squared, the third order derivative d cubed of y over dx cubed, and so on. Although taking the derivative more than one time may seem to make things unnecessarily complicated, we will actually see a useful application of this later when we study maximum and minimums of the graph of a function. However, for now, there's one last thing we have to think about in terms of computing derivatives, which is known as logarithmic differentiation, and will be the subject of the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.